Alrighty class, section 1.2, use segments and congruence. So these first two definitions are two words that we like to throw around a lot in geometry, postulate and theorem. We use them to name different rules. A postulate is a rule that is accepted without proof, and theorem is a rule that can be proven. Ruler postulate states the distance between any 2 points is the absolute value of the difference of the coordinates. So if we have A and B on a line, we can say AB is equal to the absolute value of A minus B, or the absolute value of B minus A. And so the distance between A and B is also called the length of AB, or just AB. So AB equals absolute value A minus B, or B minus A. Example number 1. Finding the length of a segment. We need to find each length. So first is the length of BC. So we see here we have BC. B is at 1. C is at 3. So we can say the absolute value of the difference. C was at 3. B was at 1. So we get absolute value of 2, which is just 2. And if we look at letter B, we have AC, from A all the way to C. We can say A is -2, and C is 3. So -2 minus 3 gives us -5. An absolute value, and when you have something in absolute value, if it's a negative inside absolute value, the absolute value, you just drop that negative, it is 5, so 5 units, one way or the other. So the distance is 5, or 5 units. So then you try, example number 1. Find the distance of xy and the distance of xz. Go ahead and pause the video, solve that, and then unpause for the answers. Right, so xy is right here. X is at 1 1/2. And we will subtract, y is at 5, so we'll subtract 5. Or if you don't want to deal with those negatives, you can flip it around and say 5 minus 1 1/2. Since it's inside absolute values, we're going to come up with the same answer either way. So 5 minus 1 1/2 would give us 3 1/2. And so our distance of xy is 3 1/2. The distance for xz. Xz is here in blue. You know, x is 1 1/2. It's our positive number, so I'm going to leave that in front this time. And we're going to subtract -3. So it's really 1 1/2 plus 3, because our two negatives make a positive. which will give us 4.5. Which in absolute value still comes out to 4.5. Now let's look at the segment addition postulate. In order for you to say that point B is between points A and C, all 3 points must lie on the same line, and AB plus BC equals AC. So your segment addition postulate is AB plus BC equals AC. So the two segments, AB and BC, added together will give you that whole length. So if B is between A and C, then AB plus BC equals AC. So AB plus BC will equal AC. So example 2a, using the segment addition postulate. So G is between F and H. They're just telling us what it looks like, so we may even want to draw a picture. We know G is in between F and H. So I'll draw my line. We have F, H, and we know G is in between. We know FG equals 6. FG equals 6, and FH equals 11. And then we need to find our missing segment GH. So we can say, take the whole, subtract by the part that we know, and come up with our answer. So we take 11 minus 6, and that gives us 5. So GH equals 5. And that's the segment addition postulate worked backwards. If we know FG plus our missing number of X, so another way I could write that, 6 plus X equals 11. We just subtracted the 6 to the other side. So we're still using that segment addition postulate, even though I was using subtraction. I just jumped a step there. Example 2b. Using the segment addition postulate, M is between N and O. And we need to find NO. So here we have some different lengths for us. We have NM is 17, MO is 3x minus 5, and the whole length is 5x plus 2. So if we set that up, we know that 17 plus 3x minus 5 equals 5x plus 2 with our segment addition postulate. 17 would be our AB, 3x plus, or 3x minus 5 is that BC, and the 5x plus 2 is AC. So then we just need to combine our like terms and solve for x. And then we'll plug x back in. So combining our like terms, (17 minus 5 gives us 12. Then combine our x's and our 12 and 2. So I'll subtract 2 over, subtract the 3x over, 10 equals 2x. Divide by 2 to get the x by itself. So we know x equals 5. And then we can take 5 and plug it back in for x to solve for NO. So 5 times 5, which is 25, plus 2 gives us 27. So NO equals 27. All right, now you try. So go ahead and pause and try this on your own. Unpause for the answers. All right, so I jumped ahead to save a little bit of time. So here are the answers. Notice on the first one, we had to do a little figuring out by fractions. So 3 minus 1 1/3 gave us 1 2/3 for YZ. And then down on the bottom, make sure you pay attention to what the question is asking for. We need to define df. So first we had to find x equals 4, but then we have to remember to plug that back in to solve for df. So df was our df equals 24 for that final answer. You still have more work to do once you find x. All right, point B is between A and C. You guys need to find the length of AB and BC, so two different lengths, given that the length of AC is 20 inches, and AB, one of those lengths you need to find, is 1/4 the length of AC. So go ahead and pause there, solve this first one, and then unpause for the answer. All right, so finding the length of AB and BC. So with AB, we knew it was 1/4 the length of AC, which was 20. So we can say 1/4 times 20, which gives us 5. So AB is equal to 5. And then using our addition postulate, BC plus 5 equals 20. Subtract 5 on both sides, get BC by itself, and BC equals 15. All right, go up down to this next one. Pause the video and try and figure that. Be sure to unpause for the answer. All right, so this next one was set up the exact same way. We knew the total length of the segments. So to find WY, we know WY was 2/3 the length of XY, so we can multiply 2/3 times XY. So it was 2/3 times 36, and that gives us 24. So WY is 24, and then we needed to use the addition postulate, or the segment addition postulate, to find XW. So XW plus 24 equals 36. Subtract 24 on both sides, so XW equals 12. All right, real quick, we need to talk about congruent segments. Congruent segments are segments that have the same length. So if we look over here at the side, we're going to be marking them with these little tick marks to show that the segments are the same length. So if we look at AB and CD, the lengths are equal. So we would say, if the lengths are equal, we say AB equals CD. But the segments are congruent. So we're talking about the segment AB congruent to the segment CD. And the congruent symbol looks like this. So that's your congruent symbol. And that's all we have time for today.